Good morning, everyone. We'll get started in just about 30 seconds. Thank you for joining me. So welcome, everyone. My name is Nathan Heston, and I'm a energy solutions trainer here at Briggs & Stratton. And to give people a few minutes to get in, today's training is on whole home backup featuring the Sol-Ark 15k and SimpliPhi batteries. Just a couple of notes as we get started. There is a Q&A feature. You should find that on your Zoom menu, and I will try to check the Q&A periodically throughout this training. I'm not joined by my colleague Daniel, so I might lapse in time in answering questions, but I'll try to get to all of the questions at the end. And if I don't have the answers, I'd be happy to dig those up for you as well. So it looks like we're getting a critical mass. The numbers seem to have stabilized, so I'm going to go ahead and get started. Feel free, once again, to use the Q&A feature of the webinar. You should be able to find that in your Zoom menu. So one more time, my name is Nathan. Welcome. I'm a trainer here at Briggs & Stratton Energy Solutions, and today's webinar is Whole Home Backup featuring the Sol-Ark 15k paired with SimpliPhi batteries. You can see an example of that on your screen with a Boss 12 cabinet and the Sol-Ark 15k. So what we're going to get into today are the basics of battery energy storage, just briefly touch on that. And then we'll talk about what is whole home backup and how it compares to critical loads backup, what differentiates the topic that we'll be discussing today. We'll look at some examples of whole home backup. We'll talk about how SimpliPhi battery options pair nicely with a Sol-Ark 15k and what those battery options are. We'll also talk about the Sol-Ark 15k features. I'll talk about the sizing for the battery bank. There are limitations to your battery bank, how small your battery bank can be and able to provide the output power to the Sol-Ark 15k. We'll also talk about setting up the inverter, programming the inverter, monitoring with SimpliPhi batteries in the Sol-Ark's app PV Pro. We'll also talk just briefly at the end about our installer program. And if you have some recommendations to how to make our trainings better, I would encourage you to fill out a survey at the very end where I'll provide the QR code for that. And so I have a number of QR codes throughout this talk. If you would like to be directed to these links, feel free to have your phone nearby so that you can capture those QR codes. First off, you seem to be interested in our training, so I greatly appreciate that. Briggs & Stratton has a number of trainings available through the Power Academy, and if you haven't made use of the Power Academy yet, please consider creating an account where you can learn about a lot of our products, including generators, as well as ESS systems, batteries, etc. Additionally, we have more of these webinars coming up. We typically do about one webinar a week. Next week's training will be on battery energy storage and generator integration with ESS systems. It's a NABCEP certified talk, and you can receive those NABCEP credits for that talk. So if you are not aware of Briggs & Stratton, as well as the history of SimpliPhi Power, just a note to mention, Briggs & Stratton's a 115-year-old U.S. company, a traditional engines manufacturer, but now we are one of two companies in the U.S. that manufacture both batteries as well as generators. So we have a comprehensive energy solutions portfolio to offer you. You might not know, you may know about SimpliPhi Power and the fact that we've been doing home battery backup, military battery backup for over a decade now, 14 years. SimpliPhi was founded in 2010 and Briggs & Stratton acquired it a couple of years ago. But Briggs & Stratton also has mobile battery solutions in the form of its Vanguard factory, which produces batteries in Alabama as well. So we are a pretty comprehensive company in terms of batteries and generators and backup. I want to point out that currently, Intersolar is underway, and I realize that many of you may not be there, but if you do happen to be in the San Diego area, we can get you a free pass if you would like to come in. And you can get that free expo pass by using that QR code there. So feel free to do that. Reach out to our team and see our team. We are currently launching our 6.6 battery. You can see the 6.6 battery in the center of the screen there. That's a stack of 3 of those at 19.8 kilowatt hours. Our next generation inverter is shown there as well, together with, that looks like a Power Protect 26K generator. And these units work well together. We are designing a complete battery backup and home backup storage system. So if you're interested about this new battery, it's coming in at a much lower price point for us per kilowatt hour. So there's going to be a lot of savings there. It's also a smaller footprint. I got to interact with this battery this past week. It's about 30 inches wide and about 5 feet tall and a 20 kilowatt hour stack, like you're seeing there on the screen. And this is going to be able to offer us a greater spectrum of battery offerings for both the Sol-Ark as well as our own inverter. And so I encourage you to use that QR code if you're interested about finding more information about this, to get on our mailing list. And we do have some promotions for launch of this battery. It should be coming out in just a couple of months. So let's jump into the topic. Battery energy storage. What is battery energy storage, right? I'm just going to give a quick overview here, but take a moment to check questions. So Thomas asked, does Sol-Ark send parts to professional homeowners or installers to make repairs without sending the entire inverter in? And that's a great question, Thomas, and I'll have to ask my colleague Dylan, who's a trainer over at Sol-Ark. I'm not sure of that. Unfortunately, I don't have much experience dealing with part replacement with Sol-Ark, although our tech support team is happy to help you with questions about Sol-Ark if you need to call us as it relates to our batteries. So unfortunately, that'll be a question for Sol-Ark, and I'm sorry, I don't know the answer. Appreciate the question. Okay, let's jump into the topic. So energy storage, and an energy storage system is synonymous in the solar world with battery backup, right? And at the core, we need a high quality inverter, and the inverter is really kind of the brains of the operation. It's what directs energy from one source to another. Typically, customers are going more and more with hybrid inverters. A hybrid inverter is an inverter with the solar charge controllers built into it, the MPPTs, as well as the ability to interface with the grid. And that's becoming more and more important as the majority of customers are now grid-tied systems, having grid-tied systems. Additionally, it's important to have a high-capacity battery bank. And that battery bank, it needs to be able to produce the output power required by the inverter and be able to store enough energy, so a capacity, to be able to deliver a certain amount of time for backup. So we're going to talk about those things. An inverter also, the Sol-Ark 15k, as well as our inverter that's shown on the right side of the screen, can control a generator. So as the batteries get low, the inverter has the responsibility of starting up that generator. And I'll show you how to program those set points into a Sol-Ark later in this talk. They will use the 2-wire start functionality of our generators. And I have some wiring diagrams and pinouts to show you on that. So what is it that causes our customers to want to install battery backup systems, or just backup systems in general, right? There's often a parallel made between inverters and batteries, as well as generators and fuel supply, right? So oftentimes that parallel is that the fuel tank is the battery, right? And that the engine of an ESS system is the inverter, taking the place of that generator. But that parallel breaks down as we get a little bit into the reasons why people are installing. So if we look at both inverters and generators, people want to have energy independence and they want to have power outage protection. And so either a generator or an inverter can offer that. Gives peace of mind, that knowledge that you'll be able to do those projects over the weekend, that a large snowstorm knocking a branch onto a power line is not going to pause your ability to participate in a meeting, etc. Business continuity, again, that's where you're going to be able to just continue doing your business practices, have access to reliable power. The generators and inverters can do that for you. Critical appliances and medical equipment, there are plenty of customers, and we hear from them, that want to be able to keep important appliances or medical equipment online at all times. Now, generators and even most inverters are not approved for life-required medical equipment, right? Even though inverter acts almost like a UPS, there are stringent requirements on UPS for medical devices. I will say, though, that this parallel breaks down here. And if we look at energy arbitrage is the ability of a system to be able to buy low and use when energy is expensive. And so one of the things you can do, if you have a differential rate, you get charged peak demand charges, like I do on my bill out here in California, is to buy the electricity when it's cheap. Typically that's at nighttime, and then use that electricity when it's expensive, typically during the day. And if you have a large differential rate, you can save money simply by doing this. The other thing about battery and inverter systems is, right, they do offer you a payback. You can make your money back on them. Once you spend your money on a generator, the fuel you have to pay for, and you're not going to get paid back by using that fuel to generate your own electricity. Typically, kilowatt hours generated by a generator system, even a high efficiency one, are much more expensive than the kilowatt hours you pull from the grid. So they're almost strictly for backup use, because financially it doesn't make sense. Of course, in the off-grid world, you don't have the ability to pull power from the grid, and you might want to run a generator. Well, you can maximize the efficiency of your generator by using a battery system, by pairing it with a battery system, so you reduce your runtime, etc. There's also the ability to integrate solar energy with an inverter system. And solar energy, you can think of solar panels like an energy pump. When the sun hits them, they pump that energy. If you have a battery system, you have the ability to store that energy and then use that at nighttime. Additionally, you can sell excess energy back to the grid, but with incentives becoming lower and lower for selling back, that becomes less of a good financial move to make. There's also the ability to do time of use savings. There are also those that are buying these systems for environmental consciousness, right? Peak demand management. Some electricity, some utilities are charging people based on their peak power draw, and so you can use CTs to monitor the current you are drawing from your utility and supplement so that you limit that from batteries. So you can supplement that energy from batteries. And then of course, there are government incentives to get people to install batteries so that in a overtaxed situation, more and more customers are less reliant on the grid. And so those financial incentives can be quite significant. In terms of the federal incentives, there's a 30% tax credit that you can take on batteries alone. You don't even need to integrate a renewable like wind or solar into your system. So there are a lot of reasons people are installing home backup. What do I mean by whole home backup? So that's the topic of today, whole home backup as opposed to battery alone backup. So partial home backup, if you look at the left side of your screen, I'm featuring our Briggs & Stratton inverter here. This inverter is smaller. It's a 6 kilowatt output, and it's really only has 40 amps of pass-through. This inverter is designed specifically to meet the needs where the Sol-Ark is just too big of a unit to do so. And so in a grid down situation, the inverter isolates itself from the grid, essentially disconnects itself from the grid, and that's a requirement of hybrid inverters. And they've been doing this for over 20 years now. I believe the first were doing this in New Mexico about 2000, 2001. So these hybrid inverters isolate from the grid. They use those batteries then to supply a subset of the loads, only the core critical loads, maybe your lighting, your communication equipment, potentially other things like heating or cooking, if you have enough battery power to do that. You can also, when the grid is down, replenish your batteries from solar. And this is an example of a DC coupled system. You can bring solar in either through AC or DC on both of these inverters. Let's look at the home battery backup on the right side of the screen. On the right side of the screen, we're looking at a Sol-Ark 15k, and essentially this inverter would, I'm sorry, my dashed line is not perfect there, but we would disconnect from the grid on the right. So if you see the grid coming in on the right side, that we would disconnect from the grid there and isolate that inverter, but all the loads in the home would be on that critical, on that loads panel. There's no separation for loads in the home. This means, of course, you could tax the inverter more than it's capable of, because by battery alone, the Sol-Ark 15k is only capable of 12 kilowatts of continuous output. But if you overload the inverter and turn the device off that is causing the overload, the inverter will reset itself and be able to back up the entire home. So yes, it is limited backup. It's not as big as a 200 amp service is 48 kilowatts. This is only able to do 12 kilowatts on battery only. If we couple solar in, and solar is in excess, we can get solar to be charging batteries. You can couple in up to, I think it's 38 kilowatts, 38.2 kilowatts on a single Sol-Ark 15k if you use both AC and DC coupled solar. With solar and batteries, you can get 15 kilowatts of load support. So you're really backing up the whole home with the Sol-Ark. Here are a couple of examples. So on the left side of the screen, we're looking at a nice looking install there. It's got 6 SimpliPhi batteries. It looks like a Sol-Ark 12k. And you can see a critical loads panel closer to the inverter. The big box in the top left looks like a DC combiner box with a breaker on it. And then on the right side, you have the main loads panel to the house. So any loads left in this main loads panel will not be backed up, only ones in the critical loads panel. On the right side of the screen, you're looking at a Boss 12 cabinet. I pulled this from the internet, so thank you to Zachary and Blue Dot Solar for these pictures. It's got a Boss 12 cabinet here that's 45 kilowatts, over 45 kilowatts hours of backup storage here. A Sol-Ark 15k, and this is integrated with a smart loads panel with a span here. So this is a backup of all the loads in the house, it looks like. Home backup systems have historically been limited to partial backup, and this really has to do with the fact that most residential connections are 100 to 200 or larger services, and that main loads panel of the house is capable of supporting 48 kilowatts of power, right? Most inverters have been much smaller than that. The Tesla Powerwall 1 came out at 3.3 kilowatts. Older inverters, a trace inverter there showing at 4 kilowatts. The Powerwall 2 went up to 5 kilowatts. Got the Schneider XW Pros there, Sunny Boys, Solar Edge inverters. But most of the inverters haven't had this capability to back up a reasonable enough proportion of that 200 amp service to really do whole home backup. Now, keep in mind, whole home backup doesn't mean that we're providing 200 amps worth of service on the panel. It does mean that we are putting all of the loads on that panel onto the Sol-Ark. And one of the nice things about the Sol-Ark 15k is you get 200 amps of pass-through. That means you don't have to run a separate critical loads panel. You don't have to parallel systems. You can simply pass all of that 200 amps worth of service through the inverter to the loads. What I'm showing on the right side of the screen, there's also been a historical reason to not power the whole home based on batteries, right? Batteries have gotten increasingly more cost competitive now with greater depths of storage. We expect 10,000 cycles out of our batteries if discharged to 80%, 6,000 cycles if discharged to 90%. And around 4,000 cycles if discharged 100% repetitively. These are large numbers of cycles. We'll give you an unlimited number of cycles over 15-year warranty. And so you're really getting some longevity with your systems now. So what this means is we're now getting to price points where it's just making more sense and even being more intuitive to simply back up the whole house. Our new battery on the right side of the screen there comes in stacks of 6.6 batteries. I don't have all the specs for that yet, but a single stack of 3 of those batteries is going to be able to deliver 20 kilowatt hours worth of service. And so that goes a long way compared to where we were 5 years ago with batteries. So when we are considering doing whole home backup, we have to consider the loads on the house. If you have a hard start 5-ton AC compressor, you're going to have a hard time running that off of an inverter. Most customers are looking at heat pumps, in which you get the ability to both do heating and cooling with electrical. The advantage of a heat pump as opposed to resistive heaters with electrical is you're moving about 3 times the amount of energy for the same amount of power draw, right? You can get a high coefficient of performance with them. I point out electric water heaters in the top left. These are typically devices that use 2 or more kilowatt hours, maybe at 1 kilowatt hour with a small resistive electric water heater. Heat pump water heaters offer some advantages. One, they pull heat out of your environment. They offer the advantage, if you have this in your garage, of acting as, or a basement, as acting as both a dehumidifier as well as a water heater. So you get that benefit of drying your air. Well pumps typically can be pretty big. It's depending on the depth of the water, etc. But we're looking at 1 to 4 kilowatts of loads there. Most people don't think about the loads of their gas furnaces, but the blower motors, of course, require certain amounts of power. 200, 300, 400, 500, 2,000 watts would be fairly large for a blower motor. They're typically smaller than a kilowatt, but that's still a considerable demand. Laundry, when you're either in a heat cycle for water or in a dryer cycle, and the dryer can pull as much as 3 kilowatts. Typical refrigerators are now very efficient. In fact, that refrigerator on the screen there is one that I run in my house. It's an LG. It has a linear compressor. This thing could probably run for 3 weeks off of, well, at least 2 weeks off of my 3 SimpliPhi batteries. So I typically run this overnight, starting with a full battery from my solar during the day. I only have 2 refrigerators. I don't have a whole lot of my battery loads when my hot tub is turned off, and my batteries are still at 90% in the morning, so I get it 1 to 2 weeks of power, and I don't have many things on. Televisions are fairly low now, unless you have a plasma TV. They're less than a kilowatt, but electric ranges can be very large, right? Especially when you're running multiple burners at once, you can get up to the 8, even 10 kilowatts. Microwaves typically aren't operated very long, so it's not the duration, but it's that power draw that if you have many devices on at once, they can overload an inverter. In the top right of the screen, I did point out what percentages these different loads take over average US households. This is from the US Energy Information Administration, and just pointing out these loads as we go into systems. So let's look at an example of a parallel SimpliPhi inverter. This is a little bit small for doing whole home backup with. Both of these inverters have a maximum of 40 amps of pass-through, so you could potentially get 80 amps of load support in your loads panel of the home. But 80 amps is on the small side. That's under 20 kilowatts of power available. So it's not ideal for a whole home backup. However, if you do have a smaller home, I could probably easily get by with this, just because most of my loads are not electrical in my house. However, I would prefer to go with a Sol-Ark 15k and move more and more of my loads to electrical. I'd like to switch my heating system to an electrical heat pump based system. What I'm showing you here is DC coupled solar. These are rapid shutdown devices, which are required on rooftop solar. A disconnect here, 2 inverters that are paralleled. I'm showing a Boss 6 cabinet here, which gives about 23 kilowatt hours of storage, with DC breakers here that are required for our inverter. The Sol-Ark has those DC breakers built into it. It has 2 200 amp breakers in it, and I'll explain why in a little bit. The Sol-Ark 15k is much better suited for whole home backup. And what we're looking at here, we can have 19 kilowatts of DC coupled solar coming into the Sol-Ark 15k. Notice the big difference here, that coming from the grid, I'm running 200 amp fused disconnect straight into the Sol-Ark inverter. No loads prior to the inverter. All the loads are coming after the inverter here. And so the inverter is capable of supplying that 200 amps, passing that 200 amps through to the loads. Additionally, with battery backup, you have the ability to bring up to 275 amps of DC continuously from the battery bank in. It can surge to 25 kilowatts, I believe 24 kilowatts of surge for 5 seconds. Again, it has the ability to bring in large amounts of solar, both DC coupled and AC coupled solar at the same time. So if you're doing a retrofit, it's got AC coupled solar, maybe you've got 10 kilowatts on the roof, you want to supplement that with DC coupled solar, you can do so. And the AC coupled solar does not influence the amount of DC that you can bring in. You can still bring in an additional 19K. Communication, so our batteries are designed to communicate with Sol-Arks. All of our batteries communicate cleanly and easily with Sol-Arks, including the new battery that will be coming out. And so this is really an ideal home battery backup system for a whole home. Also point out that the PV Pro monitoring app easily gives you information about equipment, including detailed information about our batteries. And we'll talk a little bit about that app later on. So let me just point out some information about our batteries, because we are going to talk about limitations of the batteries, how many batteries are required, etc., and so sizing details. So first, we'll note that we engineer and assemble our batteries here in California. We are a California SGIP approved manufacturer, and so if you are doing an install in California, you get the opportunity to apply for that 20% SGIP rebate on any expenses related to our batteries for your systems. That gives you an extra 20% off. We use the best lithium-ion chemistry. It's cobalt-free lithium iron phosphate. We use that because it's the safest chemistry and it gives us the longest number of cycles. Like I said, we can expect up to 10,000 cycles at an 80% DOD. And we also have a very sophisticated BMS that is designed and manufactured here in California. And we use that in our AmpliPhi and SimpliPhi batteries that I'm going to be showing you on the next page. So we have already approved the AmpliPhi battery. We've demonstrated our manufacturing process for inspectors that have come to our factory. They have not yet completed the paperwork, but the SimpliPhi 4.9 battery is underway, and we should have that approved for SGIP in the coming months here. And the Phi battery as well gets that 20% discount. And this is showing an enclosure. This is what we call an access cabinet that has our batteries built into it. Those batteries have that California manufacturer discount available through the various service providers there. So I'm showing you 4 different battery offerings we have now. These are our 48-volt battery options. We also have high voltage batteries, but that's not the subject of this talk. So our smaller format batteries come in the 3.87 kilowatt hours. These are both indoor rated batteries. However, we have the ability to put both of those batteries in our outdoor rated enclosure, either in a Boss 6 cabinet or a Boss 12 cabinet that can hold 6 versus 12 batteries. There is a limitation for the AmpliPhi batteries, the number of batteries that we can use. It's a limit of 60 batteries. That has to do with the strength of the communication signals and the ability to process as those cabling gets longer and longer in the communications loop. The SimpliPhi 4.98 battery is an outdoor rated battery. So if you are in a temperate climate like California, Florida, places where it doesn't typically get cold, this is a great battery because you can mount it outside. The new battery, the 6.6, this is a 20 kilowatt hour block, a stack of 6.6s there. It will also be outdoor rated. And I don't have many more details on this yet, but this will also be an outdoor rated battery. And so I'll be providing those details in the coming months. So these are the battery cabinets that I spoke of. These are NEMA 3R rated cabinets, temperature control with a ventilation fan that comes on based on internal temperature of the cabinets. These cabinets can be scaled to fit your needs. I'll show some examples of that in a few minutes. So let's have a look at the Sol-Ark 15k. That's one of the big topics of this training, and I want to get straight into it. Also going to do a quick check of the questions. How about Canadian winter climate? Great question, Jean-Pierre. I will be talking a little bit about one of the things that our batteries can do in cold weather. and we're constantly innovating. And I know that we have plans underway for battery cabinets for cold weather. So jumping into the Sol-Ark 15k, let's jump through the specs here quickly. So first off, this is a 15k 2-phase, just meaning split phase there. You get effortless communication with our batteries. Our batteries, BMS systems, have long been designed to work seamlessly with Sol-Arks, and we continue to make sure that any firmware changes we make are approved and integrated with Sol-Ark so that you have seamless communication. The Sol-Ark 15k is an outdoor rated inverter. You can install this inside or outside. All of the hinges, the components on this inverter are high quality stainless steel. And so it's IP65 NEMA 3R rated. It does 12 kilowatts of battery to loads. As I mentioned earlier, if you have solar available, it will do 15 kilowatts continuously to loads. It does, however, have the ability to surge. It can surge for 10 seconds. I think I said 5 earlier, 10 seconds at 24 kilowatts. So if you're starting a heavy load, you can get that surge. I will point out that this transformerless inverter is split, right? So if you go over 6 kilowatts per leg, you can have issues with imbalance. But that 12 kilowatts, typically large loads are 240 volts. So for the most part, you have the ability to start those large loads with this surge. 19 kilowatts of DC coupled solar from 3 different MPPTs. This means you could have 3 independently controlled maximum power point tracking devices to bring your solar in. You can additionally bring in another 19.2 kilowatts of AC coupled solar. And again, these two do not influence each other. If you bring in 19 kilowatts from the DC side, you can still bring in another 19 from the AC coupled PV through the gen port. You get 200 amps of pass-through. That's the big thing. This is really the big difference, that 200 amps of pass-through with this inverter. Other inverters don't have that. And so that ability to just pass all of that utility power through the inverter to the loads panel is what allows us to easily do whole home backup with just a single inverter. You can integrate up to 100 amps of generator, AC generator coming through, so 100 amps, 240 AC. You get automatic 2-wire start, and you can easily interface with our Briggs & Stratton generators. We have many examples of Briggs & Stratton standby generators being controlled by the 2-wire start of Sol-Arks. It's stackable. You can monitor as well. You can monitor that generator input. You can monitor the grid input. You can monitor your solar production. AC solar production is separated from DC, and the system's smart enough to recognize what you have. You can stack this inverter. So unlike the 8K, which was not stackable, the 12K, you were able to stack it. You can do 3-phase with 2 or more units. You can also do the same thing with the Sol-Ark 15K. So there's a long history of success with SimpliPhi batteries as well. We have been supplying our batteries with Sol-Ark inverters throughout the history of both SimpliPhi and Sol-Ark. Let's talk a bit about sizing for whole home backup. There are limitations on batteries with both how much capacity they have, and everybody knows, right? That's the size, the number of kilowatt hours your battery bank holds, the size of the gas tank, right? But there are also power output limitations of batteries, and this refers to the C rate of the battery. So C rate of 1 would mean your battery can charge and discharge safely without damage in 1 hour. Our batteries are rated at C/2, meaning that these batteries can charge and discharge in 2 hours. I will note that the new battery shown on the right side of the screen is considerably faster, charging and discharging much quicker than the C/2 of the batteries we have here. So the output of a 20 kilowatt hour bank like this is going to have significantly more than 10 kilowatts of output. But I don't have that exact spec for you yet, so I'm not going to give it. The Phi battery on the left side of the screen is capable of, it's a 75 amp hour battery. It's capable of C/2, so it's half of that 75 amps in an hour. So it's delivering 37.5 amps. The same with the SimpliPhi. They have the same battery pack. The difference is a more sophisticated and advanced BMS inside the SimpliPhi battery that allows closed loop communications. So if you're sizing a 15K inverter, you would need 8 of the 3.85 batteries. If you have 2 inverters in parallel, you would need 15 of these batteries, and 3 inverters, you would need 22 batteries to do. With the SimpliPhi, we say the number of batteries is recommended because you can use a smaller number of batteries. The battery bank itself will communicate how much power output it is capable of to the inverter. But if you use less than 8 SimpliPhi batteries for a Sol-Ark 15k, you will have slightly less than that 12 kilowatts of power output. And the fewer batteries you have, the more limited the power output of the inverter is going to be, due to the closed loop communications telling it it's not capable of that 275 amp DC input that the Sol-Ark 15k is capable of. In terms of our 4.98 or 5 kilowatt hour SimpliPhi batteries, these are the outdoor rated wall hung batteries. You would need 6 of these batteries. We recommend 6 of these batteries to get the full output capabilities of the Sol-Ark 15k, 12 for 2 parallel systems, and 17 for 3 parallel systems. Check the Q&A quickly before I move on. Are the Briggs & Stratton generators rated to run daily in summer for up to 5 hours to avoid peak load demand? Do you have a prime duty rated generator? I think the answer is yes, Kevin, but I'm going to direct you to next week's training. So some of our generators, our standby generators, are rated for standby service, but we also have continuous operating certifications for some of our inverters. Additionally, I know that some of this changed with some of our newly released software, and so I'm going to direct you to next week's training, in which Daniel is going to go all through those specs and give you integration options for generators with our inverter and the Sol-Ark inverters. Bill asks, you mentioned a Sol-Ark inverter will accept 100 amps of generator. Does all 100 amps pass through to the load, or is 50 amps to the load and the rest goes to the battery? It's 100 amps of pass through, and if the battery is in a charging cycle, you can get up to 275 amps DC of charging. So I think that's about 12 kilowatts worth of charging. So yes, you can pass it through to load, but you can also use that power to charge the batteries. And I'm not sure exactly, I think you're also asking about, does that limit the amount you can power the load? I think the limit would also depend on that generator signal as well, right? So if we overload the generator, but for a large generator like a Briggs 26K, I think you can get 100 amps of pass through, but still have battery charging. I'll have to confirm with Sol-Ark. So that was a good question, Bill. I'm sorry I don't have a better answer for you. Let's look at the inputs of a Sol-Ark 15K. And I've taken a picture of a Sol-Ark 15K from our office down in Oxnard and just pointing out a couple of things to you. So first, on the left side of the inverter, these are your battery inputs. And it's broken up into 2 200 amp breakers. And Sol-Ark did this so that you could connect your battery bank to the inverter with 2-aught cabling. With big battery banks, people are typically using 4-aught cabling, and so if you don't want to have to make some kind of combiner or use some Polaris connector, etc., compression connector to join and split your cabling, you can buy these bus bars that I've shown in the bottom left-hand corner and just combine those 200 amp breakers into single positive input and negative inputs. These are the DC breakers in the top left side. This is what you will turn on and off to connect and disconnect your battery from the Sol-Ark 15K. In the center of the screen, you see the paralleling communications ports. This is a Modbus port here, and this is CAN bus. This is where you will connect the communications of your battery equipment. So the closed loop communicating SimpliPhi batteries will plug, just a single battery needs to be connected from the loop to this CAN bus port, and I'll show you that connection in a minute. The accessories connections here I'm going to go over on a later slide, but these are your solar inputs, 3 independent solar inputs, positive, negative for 1, positive, negative for 2, positive, negative 3. You have 4 inputs per MPPT just so you can parallel at the inverter. So 3 independent controls here for that. The generator, CTs, rapid shutdown, that'll all occur here on that on the accessories bar in the center. This is your generator input. You have 100 amps through this circuitry. So we think 100 amps is right around 23K or so. So you've got a large generator input capability there. This can either be used, if you don't use it for generator input, you can use it for AC coupled solar input. Maybe you're doing a retrofit. If you don't use it for AC coupled solar, you can do this. You can use this as a smart load, and you can use this as an output controlled by battery voltage. And I'll show you how to do that in a minute. This is the 200 amp breaker that feeds the load panel. This is where output to the load panel connects to the 15K inverter. Below this is a grounding bar. Your ground neutral bond should occur at the service disconnect, and I'll show that in a minute. The neutral bar down here at the bottom is where you connect your neutral. So your leg 1 and leg 2 of your generator, your leg 1 and leg 2 of your loads, your leg 1 and leg 2 of grid are all going to occur on the top here, and then the neutrals you would use this neutral bar for. Your grid connection here, again, I mentioned this is a 200 amps input. This has to be connected through a fused disconnect, and so I'll show that in a second. So I point out again what the single line diagram looks like for connecting this. Again, that 200 amp of service from your meter can. I've heard people say this is a service entrance rated. I, in fact, have parroted that and was found out that I was wrong. Dylan from Sol-Ark let me know, no, you do have to put it through a fused disconnect. It's not service entrance rated. So come in through that, go into the grid port on that inverter. I'm showing bringing in DC coupled solar here with, these are Sol-Ark rapid shutdowns, a disconnect for the solar. You technically don't need this disconnect because the inverter has one built on the side of it. Rapid shutdown here for shutting the inverter off in an emergency. This should be easily accessible in the event of an emergency, so we can shut those loads off, and that will shut the panels down at the rapid shutdown module level at the bank. Battery bank coming in, communications ports have to be wired in. Let's skip through and have a quick look at what a system might look like if it was if we paralleled a couple of these inverters. So if we are paralleling inverters, we have to have separate connections to a battery bank, and I'm showing the use of a combiner here. Communications on the battery bank would be just a big closed loop from battery to battery, battery to battery, all the way across to these batteries, and then one home run would run from the device port of a battery into the inverter. The inverters themselves also have to be configured with communicating wires for parallel communication, showing the output here running through to a AC combiner and then running out to the loads panel. Solar coming in independently to all 6 of these MPPTs that are there. So this is what something one example of a paralleled inverters. You can of course do up to 12. Mounting this inverter, so it's a fairly heavy inverter on the order of 130 pounds or so, but it's fairly easy to mount. It's got a wall bracket at the top, which you can't see here. You mount that, and then you hang the inverter on that wall bracket and secure it. It becomes much easier to install this inverter if you use a wiring trough, and I recommend getting a 12 by 12 with variable length wiring trough to help with cable management. The inverter needs 6 inches above it or more and 6 inches below it or more. So it looks like we're barely meeting that here with this example on the left. I point out that if you are going to do a wiring trough there, you can get a template for the knockouts below, or you can simply measure off of the bottom of the inverter and show that this is showing you the knockouts on the bottom of an inverter. This template, I believe, is on Amazon from Practical Preppers, giving you the ability to just center your knockouts, your punch throughs. Let's talk about using the closed loop communication. So for wiring closed loop communications with our battery bank, we are going to daisy chain our batteries. So there are 3 different communications ports on our SimpliPhi and SimpliPhi batteries. These RJ45 connections that are labeled battery, we will do a closed loop, and we don't have any openings on those. So if there is any opening in the chain, we will have a terminating resistor there. And the job of that terminating resistor, shown here in a picture, as well as up here in a figure, is to let that chain know that we are at the end of the loop. So we'll go daisy chain battery to battery. It does not matter which battery port you use. They're both symmetrical. Battery to battery, battery to battery, and then terminating resistor. And then off that last battery, actually, it doesn't matter which battery, we will run from the device port to the inverter. That will come in. I'm showing here where that comes in. There's a CAN bus port on the center of the Sol-Ark 15k. And so that's how you wire the communications of our batteries into the Sol-Ark 15k. Once you do that, programming becomes much simpler. If you're going to use the rapid shutdown and the 2-wire start on the Sol-Ark 15k, you would do this by using pins 7 and 8 on the Sol-Ark 15k. And for a Briggs inverter, this would be a normally open circuit, a dry contactor here, and we would wire that to pins 4 and 5 on our generators. So I'm showing the Power Protect 26k as well as the 13k. And Daniel can go into more detail next week about that. It's not really generator integration into this unit. It's not really the focus of this talk. So I'm going to skip ahead. The pinout for accessories here, some things to note. The emergency stop is the 2 terminals, 11B, 12B, that are here. And you would wire your 2-wire stop button to that. I believe you only need 1 button, even if you have paralleled inverters. Otherwise, you could wire it in parallel, what you need to do if you're doing one of our Briggs inverters. Also note that the 3, 4, 5, and 6, these are your CT sensors, so you can monitor the amount of current you are pulling from the grid and export that same amount from the inverter to prevent pulling from the grid. So this way you can keep that grid import down to 0 and essentially off-grid yourself even when using a grid-tied inverter. So the pinouts are here just so that you have them for reference. I will be sending this slide deck out to everyone. Let me take just one moment to check the Q&As. Matt Buff says 18 kilowatt and up units do have EPA certification allowing for off-grid applications up to 1,000 hours. So Matt's letting us know. Matt's one of the trainers for Briggs & Stratton. He's letting us know that indeed, yes, we do have that certification. Kevin is asking, many utilities require a DER meter between the inverter and the panel box. How do you deal with that? Kevin, that's a great question, and unfortunately, I don't know the answer, so I'll have to get back to you on that. So I will save that question and look it up. And I'll send that out when I send out this slide deck. So programming information. So how would we program our batteries into the inverter? So this is the last topic I'm going to get into before we jump into monitoring. So if you look at the Sol-Ark screen, this is what your home screen will look like, talking to you about your solar production, your export to the grid. So you're exporting out 4.6 kilowatts. You're selling that to the grid. Your loads are consuming 5 kilowatts. And you're exporting or charging the batteries you're sending out of the inverter. So this is from the perspective of the inverter where that energy is going, and those arrows tell you. To do the programming, you will hit the top right corner of the screen. That's where you will get into the setup tab. And once you're in that programming tab, the setup tab, enter battery setup by selecting this button. If you want to get into basic setup, you can turn off alarms, you can adjust the screen there. Battery setup is where we'll input most of the information from the batteries. And I'll show you that CAN bus batteries will be automatically importing the majority of their information. I point out here that we have a guide, an integration guide for using our communicating batteries with Sol-Arks, and I encourage you to use this link if you're walking through this step by step in the future. I don't have time to cover everything. In the battery setup tab, if you are using communicating batteries, you want to check this BMS lithium battery checkbox there. Once you do that, it will automatically populate the majority of your battery settings. I want to point out that when you're using a Sol-Ark, it does not save any of your settings until you click OK. So if you make a change, you have to click OK before that information is actually saved. So don't just continue on and then cancel out and think that your settings have automatically saved. You can input your, if you're not using communicating batteries, I encourage you to input your battery capacity here. You can look that up on the table. Each of our SimpliPhi and Phi batteries has 75 amp hours. The SimpliPhi 5 kilowatt hour battery has 95 amp hours each. And so you would multiply those numbers times the number of batteries. The maximum charge amperage depends on the number of batteries that you have, 37.5 each for each SimpliPhi and Phi battery. 47.5 each for the SimpliPhi battery. We don't have the values yet for our bigger, our newest battery. The maximum discharge rate is going to be the same as the maximum charge rate for our batteries. Again, many of these things are going to be automatically populated if you're using a communicating battery. On the battery setup tab, this allows you to set the charge rates from grid or generator port. Now these refer to the ports, so you can set the start voltage at which charging will begin from the generator port, and you can set that as a state of charge. So you can either do things based on a voltage or a percentage state of charge. That depends on what you have chosen in the basic setup tab, whether you view your battery information as a state of charge or a voltage. Again, the similar settings are available for charging off the grid. Once you hook up our batteries, our communicating batteries, these numbers will automatically populate for you. I've given them down at the bottom of the screen. Float for our batteries should be 54, absorb set to 56 volts, and equalize is something that's used for lead acid batteries, and you want to make sure that there's 0 hours there for equalization. Again, with communicating batteries, they'll program themselves. The discharge, you can set here. Here's a shutdown voltage. This is the voltage. This is the low battery cutout voltage at which we will stop the output from batteries from the inverter. So this is done to protect the batteries. This should automatically set to 48 volts for our batteries. The low battery is basically a warning that you'll get on the inverter when you get to low battery. It will illuminate that yellow light on the main screen. The restart voltage is the voltage after we've finished a discharge cycle and we've gotten to low battery cutout, that the batteries will cut back in. So you could call this the cut-in voltage if you like. Again, automatically populated for communicating batteries, but if you're using the Phi battery, a non-communicating battery, we also have an empty battery voltage, and we use this 46 volts here. This is to protect the battery, so it will turn the inverter completely off, not just the loads off, when we reach this voltage, to protect the battery so that battery BMS doesn't shut itself down. Battery resistance, this actually varies a lot with temperature. It can be approximated by 24 ohms divided by the number of batteries you have. However, if you're in extremely cold environments, you might want to increase this number. If your battery bank is shutting down a little bit too early under load, it has to do with the battery's internal resistance, which is why you might get to the voltage where you've set shutdown to occur, but it's not going to do that because it's under a heavy load, and so the actual resting voltages of the batteries are higher. So you do want to pay attention to this and input this. If you're continuously in cold environments, you might consider increasing this number a bit in the winter months and decreasing it in the summer months if the temperature of your battery bank varies. 99% efficiency we keep here. And then the low battery settings, I've given you some guidelines on the right to what to set those to. Under grid setup, you have the ability to control a lot of things, such as time of use, limiting power to the home from the grid by using CTs, etc. And so this is overall a maximum limit of how much power you would be able to sell to the grid. You can limit the power to the home as well. So if you want to limit the power to the home, you can set those values. These time values that are here on the right side are for time of use, and there's a whole training on time of use setup that I don't have time to go into, but I've linked here. There's a video to Sol-Ark's time of use setup here if you want to take advantage of that. Time of use allows you to charge up your batteries when that energy is available or low cost, so from solar or a time when the grid is cheap, and then just reserve your discharge of your battery bank to times when electricity is expensive. Sol-Arks can also be paralleled to three-phase 208. The most common application I would think would be the two-phase, the split phase 120/240. So you get two legs of 120. But if you have two or more inverters, you can create three-phase 208 power out of them. And you would do that by using, under your basic setup, you would select parallel inverters, and then you have the ability here to do three-phase power. But this is not the talk for that. I just want you to know that that's available if you're trying to do three-phase. Here's a nice system where we've got a couple of 12Ks, it looks like, paralleled, and I'm showing you just because it's a very nice install. Earlier, it was asked about temperatures and cold environments. And one of the nice things about our communicating batteries and our fairly sophisticated BMS inside our batteries is the fact that these batteries automatically control their charge rates in extreme temperatures, which allows us to have a much broader charging and discharging range than most of our competitors. We can actually charge slowly at low temperatures. That warms up the batteries due to the high levels of internal resistance in the electrolyte at those temperatures. That heats up the batteries, and then we can increase that charge rate. So as our batteries get warmer and warmer, we increase our charge rate until we get into that optimal window from about 7 Celsius to 50 degrees Celsius. There's also the fault protection is given for you here. So if you have your batteries in an extreme cold situation, especially in like a time of use situation in which the batteries are just sitting idle and not discharging or charging, you could get into a temperature fault, which should automatically resolve itself unless you get below 21 Celsius, in which case it'll require a manual reset. So I'm just about out of time. I'm only going to touch on Sol-Ark's PV Pro app, which is a great app. The software on Sol-Ark is very good, and that's one of the reasons people want to spend that extra money on that Sol-Ark compared to some lower cost options. The 200 amp pass-through is a game changer as well, but their the Sol-Ark monitoring is also very good. So you can look over the course of a day, a month, a year. You can look in a chart format, or you can graph out your information. Here, I'm just showing a graph of one of our customers, Sol-Ark 15Ks, where we've got AC coupled solar that's here, and you can see those batteries charging up during the day and then discharging during the night. The battery graph can go positive or negative. It goes negative when that battery is charging up, and it goes positive when that battery is discharging. You additionally can see a lot of information about our batteries. It can tell you about the temperature of your battery. It can tell you about the full amount of throughput of the battery. And so you've got a lot of information about batteries here on this tab in the monitoring. So in closing, I'm just about out of time here. I want to take more questions, and I see those questions coming in. I just want to take 1 second to tell you about our Elite Installer Program. So we do have an installer program where we've got hundreds of people across the US, hundreds of companies, and I'd like to get your company on there. You additionally get some benefits. If you're installing SimpliPhi batteries, you're getting $100 cash back now per battery when you join as an Elite installer. Also, you get featured on our map. We direct business. We have customers call in, end users call in. We direct them to our Elite installers first. So if you're interested in doing this, you get a $1,000 rebate for the first ESS system you install with our inverter, our battery technology, and use this QR code to get that $1,000 off. Additionally, if you want to contribute to making these trainings better, please take the time to give me some feedback. Tell me what you want to know, what I could have done better today, or how Briggs & Stratton could offer trainings that better suit you. Use this link here. I'll also be sending this slide deck out. You can pull the link from the slide deck if you want to click on it then. We're here to help. If you have questions, reach out, training@Oxnard, training-oxnard@basco.com. Or if you want to contact us by phone, our phone number's there. If you want to talk to our applications engineers, our sales applications engineers, it's extension 2. If you want tech support, it's extension 1. Again, that survey is here, and I'm going to take the time to jump into the questions. So thank you for your attendance. Tim writes, some of the battery values get set on totals and others on per inverter share of the total. I'm struggling to keep track of which are which. Yes, that's a good point, Tim. When you are paralleling inverter systems, it becomes more complicated. And I think we'll dive into that in a later topic, or in a later training. The choice, it's similar for our inverters as well. The choice between V or percent seems to get overridden by the selection of battery type and open or closed loop communication. A bit of confusion. I'm learning to roll with it. I didn't know that, Tim. I believe if you go into the basic setup tab of the Sol-Ark, you can choose a percentage, but maybe CAN bus overrides that. I haven't experienced that before. Russ says, normally our transfer switch has a safety to keep electrical current from backfeeding to the grid. What safeties do we have for a battery being charged and a power outage occurs? How does the system know what is happening and to understand the difference? So any 1741 or 1741 SA or 1741 SB certified inverter is required to not island, right? To prevent islanding, and that means preventing that Sol-Ark from being connected to the grid, preventing that inverter from feeding power back onto a grid in a down situation. So how it knows what is happening, it's continuously monitoring the L1 and the L2 of the utility port, and it anti-islands in a grid down situation. I'm not sure I can give much more information, because feel free to clarify if I didn't answer that very well. Ralph says, I do installs at 9,000 feet. Please speak to your batteries and how they perform at high altitude. So I'm happy to say, Ralph, that our batteries use a cylindrical form factor, and our batteries would have no trouble with installs at high elevations, provided you deal with the typical cold temperatures at high elevations. So cylindrical form factor cells would be fine even under a vacuum. That's not true for prismatic cells and for pouch cells. So we will be covering that training in an extreme environments training that I believe is coming up in February. So stay tuned for that, but I'm happy to report to you that we have no problem doing installs above 9,000 feet with our batteries. And those are all the questions. Russ says, good answer, I got it. So thank you. I appreciate all of you attending. I hope you have a wonderful day. Take care.